And so the title of our talk is Bridging the Multi-Chain Universe, Ethereum and Moonbeam.
Oh yeah, great. My mic works. So let's start. Great. All right. You want to present the roadmap?
You go ahead.
All right, so in this talk, first we're going to give a little background about ourselves, explain a little bit what Moonbeam is, the project that we're working on, and then we're going to talk about using a bridge between Moonbeam and Ethereum with ChainSafe, and then we're going to move on to the demo.
And if you want to follow along, bit.ly/bridge44 to get the slides.
Oh yeah. It's in the previous slide. So my name is Antoine Estienne. I'm a full-stack blockchain engineer in the Moonbeam dev team. I worked previously at Consensus and Hypernet Labs. I studied here in Paris, graduated from Mines Paris Tech with a master's in science and executive engineering. And I've been working for Moonbeam since October 2020. And my hobbies are traveling and music.
My name is Kevin Neilson. I'm a developer relations engineer at Moonbeam. I have a degree in computer science and economics from Dartmouth. And I've been working on Moonbeam since April 2021. And cars and skiing are my two main hobbies.
All right, so let's talk a little bit about Moonbeam, the project that we're working on. So Moonbeam is a parachain in the Polkadot ecosystem. And our main goal is to provide the same user experience as Ethereum. So we want Ethereum developers to be able to use our parachain, and it would be as simple as just switching network. So we're forked out of Frontier, which is an open source project that was originally developed by Parity Tech, to which we're contributing actively because we want other parachains to be able to reuse that base layer EVM. The reason why we chose to do parachain on Polkadot is because we believe that it brings scalability and interoperability, which is today maybe the biggest challenge in Ethereum. Here we have a little picture of Frank Sinatra. Why? Because it's a funny anecdote. That's where the name of our project comes from, a jazz standard called Polkadots and Moonbeam that Frank Sinatra sang, amongst many others. So in this slide, we have a little diagram showing the different layers that make our product. So at the bottom, you can see the EVM, which is the base layer. So many other parachains have worked on replicating the EVM layer, which means that you can deploy a Solidity smart contract on our parachain with exactly the same user experience. But we spend some hard work improving that user experience. So those are the layers that you see on top of it. The first one is the Web3 RPC. So we completely replicated the RPC interface that Ethereum provides. That means that if you're familiar with Web3.js or Ethers.js or any types of RPC library that dApp developers use, it's going to be super smooth. It's going to be the exact same RPC call, so there's absolutely no work to migrate to Moonbeam on that side. On top of that, we have the unified accounts. So Kevin, so the unified accounts, it means basically that you can just use the same H160 Ethereum addresses as in Ethereum and the exact same cryptography libraries. And so once again, there's absolutely no work to migrate to our blockchain. And finally, the cherry on the cake is the DeFi integrations, because what makes the Ethereum ecosystem so great for dApp developers is all these infrastructure and tools that improve the experience. So I'm talking about Chainlink, I'm talking about bridges, that's what we're going to talk about today, but we also integrated the graph and many more, and that's thanks to our dev relations teams that has been working really hard on those integrations. So here we're kind of displaying how we're acting as an entry point for Ethereum developers to a whole ecosystem of interoperability. So on the right, you can see some projects that we've integrated with. The idea is that if you've already developed an app on Ethereum, you can just migrate to Moonbeam, and then all of a sudden you have access to all these bridges, and that really multiplies the possibilities. So just a little clarification, because you might have seen Moonbeam and Moonriver. Why do we have two names? It's because Moonbeam is the name of our parachain on Polkadot, and Moonriver is the name of our parachain on Kusama. Kusama is the canary network of Polkadot, and that's why we're going to deploy first on Kusama with Moonriver. So now let's talk a little bit about bridges. So of course, we all want a bridge that's decentralized, it's fast and secure, and compatible with all the blockchains. So that's what we want on our parachain. Let's talk about like the implementation of such a bridge. A really simple idea would be, if I have tokens on two blockchains, I can make a promise to people: you send tokens to my smart contract on Moonbeam, and I will give you tokens on the Ethereum blockchain, and vice versa. So that's like really simple, it works. The problem is that all the power is concentrated in my hands. You have no guarantee that I will actually give you the transfer on the other blockchain. So that's why we were looking for actually decentralized solution. And that's where we enter Chainbridge, which is modular, multi-directional, and decentralized. So it's using a network of relayers to guarantee decentralization. And what we like about it is that it allows multiple actors to propagate those signed messages, signed transfers between two blockchains. So that's why we chose to integrate Chainbridge into Moonbeam. And now Kevin is going to tell us a little bit more about that.
So let's talk a little bit about how the chain-safe bridge works. So the transfer flow is that the user first initiates the transfer on the source chain, and an event is emitted. Then you have relayers who are observing and listening for these events. They make sure that the message is formatted correctly. Keep in mind that chain-safe is a message passing protocol, so they check that the message is formatted correctly, and it's parsed, and then it's moved on to the destination chain. And it's proposed on the destination chain, and it has to be set for a vote so that no one relayer could do anything malicious. If the vote threshold is met, it doesn't take very long, but a couple of confirmations and the proposal will be executed and finalized. Something to mention as well is that in the current implementation of ChainSafe, there is an admin, but that's something that would fade away in terms of importance. Admin being able to, pause the contract. After the initiation, right? This flow is showing a lot of steps, but this is not complicated for a user, right? The user presses one button as long as they have their wallet set up correctly. They're on the right network, that type of thing. They're not pressing, 1,000 buttons. So also, let's talk about the two models of token transfers that are supported now. The first one being lock and unlock, and this is the simplest one, and it might be what comes to mind, when you first think about a bridge. And what this model is you have a bucket of tokens on one bridge and a bucket of tokens on the other bridge. And if you lock tokens on one bridge, you send it to the handler contract, and they get locked, and then they'll be unlocked on the destination chain. Now, what this requires is that the destination chain has to have a large amount of tokens to unlock, and so these can be thought of as kind of pre-minted tokens or already allocated tokens. They have to be sitting there waiting just on the destination chain. This creates a couple of minor headaches, right? So for one, the contract can't run out of tokens, right? So if the contract on the destination chain were to run out of tokens, the contract would stop working. Secondly is who has the authority to mint tokens, who sends them to the contract, that type of thing. And then a third issue is just it's a large honeypot of tokens, right? Just sitting there waiting and somebody might try to attack it. So that kind of brings us to the next token model, the lock, mint, and the burn unlock model. So similar, but slightly different, right? The way this works is that on the destination chain, the contract has to have the ability to mint tokens. And when we say mint tokens, we mean that we are minting representations of the tokens that were on the original chain. So these are not original, but they are, representations of that token. So again, somebody sends it into the contract, locking it on the destination chain, and same flow that it goes through. And then on the destination chain, these tokens, the wrapped representations, they're created. So what happens when it's going back the other way? When it's going back the other way, the origin chain is what the prior destination chain was. And so a user sends them, burns them, and they can't just burn them to a random address that's zeroed out. They have to actually send them to the contract itself. It gets verified, that those are completely destroyed, and then the original tokens are unlocked, and the user is able to move them. And again, this is all done under a multi-sig threshold, right? So if somebody just sends tokens to the one of the handler contracts, nobody can take that out. Not the team, nobody, anything. All of it is done under a multi-sig contract. So let's talk about transfer types. Sorry. So transfer types, right? Thinking about it abstractly, right? Chain bridge is a message passing protocol. You can send anything you want. But there's two specific ones that you're typically going to be sending, and that's fungible ERC20 tokens, and you can also send non-fungible ERC721 tokens. So the generic handler can control any type of message, right? If you're sending an ERC20 token or an ERC721, you want to send it through those specific handlers because they're more gas efficient and there's more controls around them. But again, you can send anything you want between the two. And I think I mentioned it, but the fungible and the non-fungible, those are just variations of the generic handler type. So this is a hands-on workshop. Feel free to participate if you have MetaMask, if you have your computer open and ready. If not, that's okay. One disclaimer is just that the demo is all set up on my Mac, but it's not set up on the Windows laptop here, and Macs are not compatible even with an adapter with this presentation. So that's okay. We are prepared. I have some appendix slides with screenshots, so you'll be able to see exactly what it looks like. But this is meant for you to participate if you'd like to, so please do if you have your laptop with you. So the first thing you're going to want to do is set up Moonbase Alpha on MetaMask. So this is our testnet, and it's easy to get set up. We have the name being Moonbase Alpha. We have an RPC URL of rpc.testnet.moonbeam.network. We have a chain ID of 1287, and then our currency symbol being dev. So if anybody wants to follow along in the presentation, you can, and it's bit.ly/bridge44. Okay, the next thing you're going to do is get Moonbase Alpha tokens from our Discord bot. We also have a link here for the Rinkeby ETH faucet, because if you want to send tokens the other way, you got to have funds on both chains. So faucet.rinkeby.io. Also, if anybody had any issues, you can just fill in your address at this form, and I'll send you tokens for both. So that's bit.ly/LOB test, League of Bridges test. Okay, and so for the demo, what we'd be doing is minting ERC20 tokens. ERC20S, that's just a generic test token, very creatively named, ERC20S. So these can only be minted on Moonbase Alpha. So if you navigate to this link, moonbasechainbridge.netlify.app, you'll see this interface here. And you'll just choose, you'll make sure that you're connected to Moonbase Alpha, and then the destination parameter is not really relevant for this because we're just minting a token. And then it'll mint you 5 tokens. The next thing you'll do is just the other tab. So moving from the Mint ERC20S to the transfer tab. And again, you want to make sure that you're connected to Moonbase Alpha and MetaMask, and that's the one that is selected. You're going to choose the destination network, which is Rinkeby. You can also do Kovan, but Rinkeby was just suggested. That's what I suggest in this case. It's easier to get testnet Rinkeby. So you specify your destination address. You can just choose, I want to send funds to my address. You don't have to pre-fill anything. It just pre-fills it for you. Okay, you press submit. So it's one button where you press submit. And then what you'll see is you'll see that the transfer is in progress. So it'll start with 0 out of 1 signatures. And then it'll confirm with at least 1 signature. And then that will continue. Now, something to keep in mind is that there are multiple people who are required to vote, even though there's only 1 signature that's needed. So it's gas optimized. So if somebody, let's say a signature has already been received, but everybody else is also required to vote, they will submit a transaction to vote, but it won't go through all the way because it's already passed. So that's saving gas there. Pretty soon after that, you'll see that the transfer has been completed, and then you can view it in Etherscan Explorer. In the case of making a transfer the other way, you can see the transaction in our block explorer for Moonbase Alpha. And you can reverse the transfer as well, right? So similar settings here. This is all live. This is not like a demo or anything. All of this is live, and you can take care of it right now. So before we leave, we just wanted to show you some of the tools that you can use if you want to go beyond Chainbridge, right? So we have a host of tools that Moonbeam works with, everything that you use to MetaMask, Remix, Truffle. We have block explorers that are live, including Block Scout with advanced indexing features. We also have a number of indexing protocols, including the graph, which is amazing. We have the bridges. We have pub and sub, so you can subscribe to events from contracts. All this is quite advanced, and it's not, it's completely live and ready now. This is not like a proof of concept thing, or this is not, forward-facing guidance. This is all things that are live right now. So how do you get started? You can go to docs.moonbeam.network. You can connect your MetaMask to Moonbase Alpha, get some tokens, and then you can interact with a number of dApps without going to Remix too. So you can get started with the Minter, you can get started with Moonlink, and then with the Chainbridge UI. And also how to get in touch with us, moonbeam.network, moonbeam.foundation. You can join our Discord and also check out our GitHub repos. That's it for the demo portion, but feel free to let us know if you have any questions, or feel free to contact us if you have any troubles with and I don't know if we have a ton of time. I think we just have like a minute or two before the next.
And also, don't forget to mention that at 4:45, if you like this presentation, we're also presenting on another subject, which is enhancing Ethereum smart contracts with precompiles. And it's at 4:45 at FCC today.
Second floor.
Second floor.
Thank you so much.